For number 16 here, it says to find the dimensions of a rectangle, and it has an area of x squared plus 2x minus 35. So in other words, we have some sort of box. If I were to fill this in, it's like a weird measurement, x squared plus 2x minus 35. Not really how we think about area, but if I were to think about how we've done these problems, we typically have our highest power at the top left, and then here our lowest power on the bottom right. So we have x squared, and then we have minus 35 on the bottom right. We have 2x, but I'm not sure how those numbers go because it could be positive, it could be negative, and it'll still add up to 2x. So what I can do though is I could factor. So I'm going to factor this here, use my x factor. And so how this one works, oops, let me do it down here actually. Let me go through the steps as well. So you take your a, b, and c. So a here is 1, b here is 2, and c here is negative 35. You take your a times your c, so you get negative 35. 1 times negative 35. And then you have your b, which is just 2. You want to find two numbers that multiply to negative 35, and those same two numbers, they add up to 2. So if you think about it for a moment, you might end up with something like 7 and then negative 5. So you could double check, does 7 times negative 5 give us negative 35? Yes, it does. And 7 plus negative 5 gives us positive 2. So our values here are 7x and then negative 5x. And they could be switched around, the 7 and the negative 5x. That's fine. You'll get the same thing. So what I do now is I take a look at either a row or a column and find the greatest common factor. For that column, it's just x. So if this is x, how do I get x squared? It's going to be another x times x. Then you just keep going. What times x gives us negative 5x? Negative 5. What times x gives us 7x? It's going to be 7. And double check, does 7 times negative 5 give us negative 35? Yes, it does. So the last thing you have to do is just write it as a final statement. So our dimensions are x plus 7 and then x minus 5. And you could have this switched around. You could have x minus 5 times x plus 7. Same thing. All right. So that's number 16. Number 17 is very similar, except different numbers, really. So I'm going to do the same process as I did earlier. I might squeeze it in here, though. I'm going to zoom in a little bit. So we have our a times c. So you might need a calculator for this. I guess you could check if there's any greatest common factors in here, but I don't see any. So I'm going to have 14 times my negative 5. I'll get negative 70 on top. And then on the bottom, I'll have negative 33. So it might take a little bit for you to think about. But what you can do is you could think about the factors of 70. Like, what are two numbers that multiply to 70? Well, there's 1 and 70. I could do 2 and 35. I could do maybe 7 and 10. Let's see if there's anything else. Don't think there is. But from here, I can tell from my factors, how could I get 33 and then negative 33? It's going to be using these two factors. So 2 and 35. And how could I get negative 33? Well, it's if I have negative 35 plus 2. So our area model is going to look like this. We have 14x here squared, negative 5, and then we have 2x, and then negative 35x. And so what would my side lengths here be? I'm going to look at this side here because I can see the GCF a little better. I can tell I could factor out a 2 and then also an x. And so here, if this is 2x, well, I know this is going to be 1 over here. What times 2x is going to make 14x squared? That's going to be 7x. And then 2x times 1 is 2x. That's how I solved that. And you keep going, 7x times negative 35x, or what times that gives us negative 35? It's going to be just 5. So for this one, double check. 1 times, missing a negative. Negative 5 gives us the negative 5 there. And so our final dimensions, our side lengths, 7x plus 1, 2x minus 5, like so. All right, so that's number 17. All right, this next one here, number 18. So this one here, it says solve by factoring. So key thing is you have to make sure, because it's an equal sign, you have to make sure it's in standard form. So it has to equal 0. So in order to do that, I'm going to have to subtract 44 from both sides. So I'll get x squared plus 7x and then minus 44. And so from here, I could find my a, b, and c if you like doing that, or you could just go straight to your x factor. So we get that there. A is 1, b is 7, c is negative 44. So set up your x, negative 44 here, 7 over here. So what two numbers multiply to negative 44, but add up to just 7? So it might take you a while, but for me, I could figure this out after thinking about it. It's going to be 11 and then negative 4. So our factors are 11 and 4, so draw your area model. Let me make this bigger here. And so here we'll have x squared, here we'll have negative 44, and then in our other boxes we'll have 11. Okay, so there you'll have 11x, and then on the other one you'll have negative 4 here. So you have to find your side lengths again. Here we're going to have x and x, and it's going to be negative 4 and 11. So if we take a look at this here, if I write it up, it's going to be x plus 11 times x minus 4, and then equals 0. And so to solve this, it's two numbers being multiplied to give us 0. So how is that possible? Well, either x plus 11 has to be 0, or this x minus 4 has to be 0. And so if you solve, subtract 11, plus 4, your final answers are going to be negative 11 and positive 4. All right. And so it does say to solve, so you do have to find your solutions to it. If it didn't say solve and it just said factor, then you could stop over here. But it does say to solve.